Hello students, good morning. In previous class already we discussed about the emission spectrum and absorption spectrum. What do you mean by emission spectrum and what is a spectrum? Okay, absorption spectrum. Understand? So let's see what is emission and what is absorption spectrum. Emission spectrum is, you know about the emission spectrum is the obtained when radiations emitted by the excited substance, okay, are analyzed with a spectroscopy. Okay, when we analyze a spectroscopy through the spectroscopy, you know about now excited, okay, this is first state when the this is the nucleus, this is the okay first orbit, second orbit. So when energy orbit of the first electron, this is the second energy state E2. So this is the known as ground state and this is the excited state. Okay, so after the okay energy passing from the ground to excited, understand? So we have to given there कि radiations emitted by excited substance, okay, radiation obtained by excited substance then analyzed with the spectroscopy. So this is known as emission spectra. Okay, emission means how many okay spectrum is emitted on that surface. Understand? While absorption spectrum, the absorption spectrum is obtained when the white light is first passed through the substance. Okay, substance means any gaseous atom जैसे hydrogen gases या any other. Understand? And the transmitted light is analyzed with a spectroscopy. ठीक है, and after light क्या कि when by the spectroscopy when we analyze कि which है ना light is transmitted, how many lights, what is their spectrum, what is their frequency, then this is known as absorption spectrum. Okay, second case, emission spectrum consists of bright colored lines separated by dark space. What is emission spectrum consists of what? Bright color, जो क्या होता है bright चमकता, okay चमकीला lines, और जो क्या होते हैं separated by dark space. यहाँ क्या होती है dark space between the two okay two rays, okay two colored, there is a dark space between them, that is known as emission spectrum. But in case of absorption spectrum, कि absorption spectrum consists of dark lines, okay dark lines in an otherwise continuous spectrum. Okay, it also contains the dark lines. Understand? It all lines contain dark. Understand? So this is known as what? Absorption spectrum. Okay, so this is the discuss about the what emission and absorption spectrum. Now let's we discuss about the what emission spectrum of hydrogen atom. What is the emission spectrum of hydrogen atom? Understand? So you know about the spectrum of hydrogen atom can be obtained by passing an electric discharge. You know about when we a spectrum of hydrogen atom can be obtained when passing electric current, okay electric discharge through the gaseous atom, hydrogen gaseous atom या any atoms in discharge tube under a low pressure. So the emitted light is analyzed with the help of a spectroscope. Okay, so emitted light के how many light is emitted, that is what is their frequency, what is their wavelength. Okay, so after the analyzing by spectroscopy, understand, then we conclude. So the spectrum consists of a large number of lines. What? The spectrum consists of a large number of lines, okay, appearing in different regions of wavelength. Their wavelength are different. You know about now. Some of the lines are present in the visible region. While others in ultraviolet and infrared. Understand? When we okay after okay gas is passing through, just like I say here. Understand? Ultraviolet. See here na? When gas is passing through the gaseous atom, then it's ultraviolet region. This is the ultraviolet, this is the visible, this is the infrared. Okay, so different regions are occurred. Understand? Due to their different wavelength, different frequency, okay, and given by the different, analyzed by the different scientists, just like a Lyman, Balmer, Paschen, okay, different regions. Understand? So in case of that analyzed by the Balmer, J.J. Balmer developed a simple relationship among the different wavelength of the series of visible lines. You know about the different visible, okay, wavelength of the visible lines in the hydrogen spectrum. So the relation you know about the spectrum is क्या? When a ray of light passing through the prism, then it splits into different 7 color. So that is known as spectrum. So this case is also happen in this case. Okay. So in this way, what is given there? In this case also given there. Okay. So what is given there? कि Balmer developed a simple relation among wavelength of the series of visible lines in hydrogen spectrum. Okay, he gives the following relation. What is the relation? कि 1 by lambda that is क्या है? Reciprocal of wavelength is known as wave number. You know about ना? Reciprocal of wavelength is known as wave number, which is denoted by nu bar. Okay, which assign it per centimeter per meter. तो इन दिस केस 1 बाई लेमडा या भी हाँ ना न्यू बार इक्वल टू 109677 ओके इंटू 1/2 का स्क्वायर माइनस 1/n1 का स्क्वायर. ओके दिस इज द गिवन बाय हाँ ना एक्साइटेड स्टेट टू ग्राउंड स्टेट. ओके ग्राउंड स्टेट टू एक्साइटेड स्टेट. दिस इज द ग्राउंड स्टेट एंड दिस इज एक्साइटेड स्टेट. तो दैट इज ऑब्टेन हाँ ना बाय द स्पेक्ट्रोस्कोपी. दिस इज गिवन बाय द बाल्मर. ओके जस्ट लाइक सी हियर. तो यू नो अबाउट n is an integer. Okay, n is an integer equal to greater than 3. Understand? Where n equal to 3, 4, 5. You have seen na? N equal to 3, 4, 5. It is known as Balmer formula. Okay, greater than 3. N equal to greater than 3. And n1 क्या है? n1 equal to 2. n1 equal to 2 and n2 equal to what? 3, 4, 5. That is known as Balmer formula. Okay. So in this way, the Balmer formula gives only the spectrum lines in the visible region. So these regions of lines which appear in visible region, okay, named as Balmer series. तो this series of lines which appear visible, ये कौन से region में appear होते हैं? Visible region में. Okay, that is known as Balmer series. Understand? तो soon afterwards a series of spectral lines, hydrogen atom in different regions were discovered. Okay, different region, different there है ना space. Region means space. तो these lines in different regions were grouped into 5 different series of lines. और ये कैसे आकर होते हैं? डिस ग्रुप इनटू 5 डिफरेंट रीजन्स लाइंस, ईच बीइंग नेम्ड आफ्टर द नेम ऑफ डिस्कवर्ड. और प्रत्येक का नाम अलग अलग दिया गया है आफ्टर डिस्कवर्ड. जस्ट लाइक ए नो दीज आर लाइमन सीरीज. ओके फर्स्ट लाइन, सेकंड लाइन बाल्मर सीरीज, थर्ड पासन सीरीज, ब्रैकेट सीरीज एंड पीफन सीरीज. डिफरेंट लाइन अकर्स. ओके विच नेम्स डिफरेंट. तो लाइमन सीरीज अपीयर्स इन द अल्ट्रावायलेट. लाइमन सीरीज अकर्स इन अल्ट्रावायलेट रीजन. बाल्मर सीरीज अपीयर इन विजिबल रीजन, while in other 3 series in the infrared, and other 3 infrared region occurs. You know about na? See in this figure is also denotes. See here infrared given there na. कौन infrared who occur? Paston, Pfand and Brackett, which occur the infrared region. These 3 Paston, Pfand और Brackett. Balmer only contain क्या? Visible regions. Balmer see here na, Balmer series contain ultraviolet contain what? Lyman series. Lyman series contain what? Ultraviolet region. Okay, so this is the spectrum of hydrogen atom given by the different series or different line. Okay, so same regions is given there. Okay, so this is the series and region. Okay, occur by the different series. Okay, different regions. Now we'll discuss about. Okay, now we'll discuss what Rydberg equation. What do you mean by Rydberg equation? What is Rydberg? The Rydberg is scientist. You know about na? Who given the expression या formula to finding the spectral lines, different spectral lines, or है ना, also we can say that. So as the other series of hydrogen spectral lines were discovered, a more general expression was found. You know about this is the general expression. 1 by lambda या new number equal to r. R means Rydberg है ना constant. 1 by n1 का स्क्वायर माइनस 1 by n2 का स्क्वायर. n1 means क्या? This is the form of ground state and this is the excited state. Ground state to excited state. तो where n1 and n2 are integers such that n2 is क्या है? Greater than n1 है ना. n2 क्या होगा? n1 से greater है. तो r is constant, now called Rydberg constant. You know about which value is क्या? Fixed constant 109677 per centimeter. So the expression is found to be valid for all the lines in the hydrogen spectrum and is known as Rydberg equation. Okay, this equation known as Rydberg equation. Okay, no problem. अब limiting line. You know about limiting line? So the limiting line of any spectral series in the hydrogen spectrum is the line when n2 in the Rydberg equation is infinitive. That is n2 क्या है? Infinitive है. Okay, n2 कुछ भी आ सकता है 3, 4, 5, 6. n2 equal to what? 3, 4, 5. But n1 क्या रहेगा? Fix. जैसे n1 fix है 2 second period, second है ना orbit. Okay, but n2 क्या है? है ना infinite 3, 4, 5 any number of cell है ना jumps any. Okay. It jumps from any lines. Understand? So this line will have the shortest wavelength and largest wave number. You know about na shortest wavelength? This line will have shortest wavelength and largest wave number. So the complete spectrum of hydrogen atom is this is just like given there. Already we discussed what is the limiting line given there na. Okay, this is the spectrum given by the different line hydrogen spectrum occur by different series or different regions. Okay. Understand? This is the spectrum. You know what? When a ray of light passing through the regions, then it's obtain the different colors. You know what? Visual given there. Violet, indigo, blue, green. This is the spectrum, visible spectrum. Okay, obtaining visible spectrum. Understand? Already we discussed. Understand? And you know about this is the relation between already discussed in previous class, previous lecture. Okay, what is the relation between wavelength and frequency? This is the wavelength. This is what frequency new. Okay, if wavelength increases, then frequency will decreases. This is the relation between reciprocal. Wavelength increases, then frequency will be decreases. If frequency increases, what frequency increases? Understand? Then wavelength decreases. See here, minus. Understand? So this is the relation between already we discussed. This is the visible spectrum. See here na different colors is obtained in at different wavelength. Okay, so already discussed this. Understand? Now we'll discuss about the emission of line spectrum. Understand? All see given there. Already we discussed. So now we discuss about the for a given spectral lines. Okay, spectral lines given there na. See here. What is the spectral lines? N1 remains constant while N2 series N1 plus 1, N2 plus 1, and मतलब क्या? N2 is infinitive. N2 equal to infinitive. Okay, ये कुछ भी आ सकता है 3, 4, 5, but N1 क्या है? Fix. Ground state is fixed 1 या 2, first orbit या second orbit, but N2 equal to infinitive. Okay, it jumps the energy level या electron jumps from any orbit, from ground state to excited state. So line in the same series, for example Lyman series, you know about na, this is the Lyman series. N1 equal to 1, then N2 equal to what? 2, 3, 4, 5, infinitive. Okay, move to infinitive, till infinitive. And for Balmer series, N1 equal to 2, then N2 equal to what? 3, 4, 5, all the series. Regions in which line appear in the values of N1 and N2 are given in a table, just like I see here. This is the table. This is the series different by different scientists given by region, which occurs region, value of ground state N1, excited state N2. Lyman series it occurs ultraviolet region N1 equal to 1, N2 equal to 2, 3, 4, 5. Balmer visible region N1 equal to 2, N2 3, 4, 5. Passion region infrared. Okay, the Passion bracket of P-fund, which all three occurs in infrared region, and N1 for Passion series 3 bracket 4 P-fund 5. So this is the fixed ground state. After excited state, what? There N2 is equal to increases 1 value. This is 3. So here is 4, 5, 6, 7. Here is the 4. There is 5, 6, 7, 8. 5. There is 6, 7, 8. Understand? So it may be noted that the above equation is true only for the spectral lines of hydrogen atom or hydrogen-like ions. You know about hydrogen-like ions or hydrogen spectrum. So hydrogen-like ions are those which contain only one electron. You know about hydrogen. You know about which contain one electron. That means hydrogen. For example, He plus, Li2 plus, helium, lithium, 2 ions. etc. are Rydberg equation for hydrogen-like ions. Okay, may be expressed as. So also we can express this just like a hydrogen ions by the Rydberg equation, just like I see here. How can we express? So 1 by lambda equal to nu bar equal to r. R is the Rydberg constant. 1 by n1 ka square minus 1 by n2 ka square into z square. Okay, you know about r is the Rydberg constant. Z is the nuclear charge. What is the? Where z is the nuclear charge, which is equal to atomic number. You know about atomic number, just hydrogen of atomic number 1, helium atomic number. What is the atomic number? Helium 2. So this is the z, nuclear charge या atomic number, which is equal to atomic number. R is the Rydberg constant. You know about Rydberg constant. For example, He plus, Z equal to क्या है 2. Lithium, you know about what is the atomic number of lithium? 3, and so on. Understand? This is the value. Understand? Just like I see the example here. Okay, second one example is given there. Okay, how can we find the color of radiations? So what is the wavelength of light emitted when electron in hydrogen atom undergoes transition from an energy level with n equal to 4 to an energy level with n equal to 2? So what is the color of the radiations? क्या करा है in this question? What is saying there? तो क्या करा कि when hydrogen atom undergoes transition from energy level n equal to 4, एनर्जी लेवल क्या है 4 to कहाँ पे मूव कर रहा है? एनर्जी लेवल विथ n equal to 2. Understand? So here is given that what n1 equal to given that this is the ground state and this is the excited state N2. So in this question N1 equal to what? 2 or N2 equal to 4 given that. Understand? So you know about what is the Rydberg equation, 1 by lambda equal to R, N1 का square minus N2 का square. You know about this is a Rydberg constant value. Put down their value, N1 equal to 2, N2 equal to 4. So 109 putting there, and N1 equal to 2, N2 equal to 4. After that calculating them, then we obtain these itna per centimeter. Okay. After we are calculating them ना, you know what this is the value of 1 by lambda. The thing we have to find lambda, then its reciprocal. क्या हो जाएगा? Opposite. 64 is क्या है? In case of numerator and this is denominator. Then क्या होगा? This is the इतना per centimeter. This is the wavelength. Okay, this is the wavelength of that's color which fall from ground state to excited state. Understand? So this is the value of what? Wavelength. यानी कि this wavelength of this radiations occur. So then we have to again find what is कि देखिए lambda equal to इतना also भी you know about 1 nanometer 10 का power minus 9 meter means क्या nanometer. Nano means 10 का power 9. So we have to convert them with nanometer. 486 10 का power minus 9 इतना nanometer. So this line corresponds to bluish green color because nanometer given there ना. So this also what we can say that this color is bluish green color. Why bluish green? Because here given there ना इतना per centimeter. So we have to convert them into nanometer. Then this nanometer is obtained. That is means क्या? Which color is obtained? Bluish green color. Which color? Okay, I hope you are understand. I hope you all are understand because given there 486 nanometer. So nanometer given their color na. So there is table कि how many nanometer which color obtained. Okay, so in 486 nanometer, so it's obtained bluish green color. Understand? Because see here different color is given there in nanometer. 486 given there means क्या it between the 486 na where it obtained the 500 and 450 nanometer. ठीक है. तो so it obtained the bluish green color. But this is the different metals, sodium, mercury, different metals. So this is the given the table. So it's obtained what? Which colors? Bluish green color. Okay. I hope you all are understand.